Francke, and this is my Physics 2 Lab 1. Starting off with the introduction, the purpose of this lab is to electrically charge pieces of tape to observe their interactions and determine their charges. Some key concepts: Coulomb's law, whose equation can be seen on screen, was used since we assumed that the tapes that were electrically charged in this experiment are to be treated as point charges to simplify calculations. Newton's second and third laws were also used. Electric field's equation, which could also be seen on screen, was used to calculate the fields that were produced by the charged tapes. The gravitational force was used to find the gravitational force acting on the tapes in some later experiments, and a basic understanding of vectors is also needed. Moving on to the main results, some of the observations when the tape was made to interact with different objects. A hand which was neutral was attracted to the U-tape. Another U-tape which had an unknown charge, the U-tape was repelled by it. A book with neutral charge, the U-tape was attracted to it, and the pen with negative charge, the U-tape, was also attracted to it. These resulted in the conclusion that the U-tape is positively charged. Some of the assumptions used in the experiment is that the tape in this experiment was treated as a point charge in calculations, with the tape's total charge being represented as a concentrated charge at its center. This could leave room to possible error because in reality the tape is a strip of mass that has charge distributed along it. This is done so that we could use Coulomb's law for the electrostatic force of a point charge. The tape is assumed to have the same charge each time along the entirety of the tape as well, and humidity is also assumed to be negligible, since this could cause a loss of charge over time for the tape. The basic procedure of the experiment: a piece of tape was stuck to a flat surface, another piece of tape was then stuck to the previous tape and quickly removed in order to give it an electric charge. This charged tape was then hung from a table, and its interactions with neutral and charged matter were then observed. Finally, the tape was attached to two books to see how close another equally charged tape had to be to produce a repulsive force strong enough to make it float and counteract the force due to gravity. All observations were recorded. Some data from the experiment: the constants were the length of the tape, which is 0.2 meters, mass of the U-tape 2e to the negative 4 kilograms, distance between tape A and B in order to cause tape B to float, 0.0367 meters. The force of gravity was calculated to be 1.962 e to the negative 3 newtons. The electric field force was found to be the same thing, 1.962 e to the negative 3 newtons. And the charge of the tape was used using Coulomb's law, which was 1.709 e to the negative 8 coulombs. Moving on for more experiments and the calculations found using the data. Number of atoms on tape B was found by dividing the area of the tape by the area of the atom, and found to be 4e to the 17th atoms. The ratio of electrons per atom was found by dividing the total charge on the tape by the total charge of an electron, which is found to be 1.068 e to the 11. And then the ratio of electrons to atoms was found by dividing the number of electrons by the number of atoms, which is then found to be 2.67 e to the negative 7 electrons per one atom. A glow script simulation was used to create a model for this experiment. In the glow script model, both tapes were treated as point charges as done in the calculations above, and the electric field force of the top tape due to the bottom tape was set equal to the force due to gravity, and then Coulomb's law was used to find the charge, or Q, of the tape in order to cause the top tape to float as it was in the experiment. Some of the questions from the glow script: what was the magnitude of the charge on one piece of tape as calculated by your computational model? This is found to be 1.716 e to the negative 8 coulombs. What assumptions, approximations, or idealizations did you have to make to determine the amount of charge on the floating tape? We had to assume that the tape was a point charge with all the charge concentrated at the center of the tape, and assume that each tape had about the same amount of charge evenly distributed along the length of the tape. Some of the discussion questions: what if electrons had positive charge and protons had negative charge? How would this change the observations you made with your tapes and other objects? The only observation that would have changed is that the tape would have been repelled by the pen, since this time, instead of losing electrons and gaining a positive charge, it would be losing positively charged electrons, therefore leaving a negative charge and therefore repelling the negatively charged pen. Why is it important to handle the charged tape as little as possible? What happens when the tapes come into contact with your hands or other objects? The tapes distribute their excess charge onto the surface of the object it is coming into contact with, i.e. your hand or the table. This results in the tapes having effectively no more excess charge since it was distributed over such a large area.